We are continuing with transformations of cubic functions. We're on example 3, writing transformed cubic functions. Let f of x equals x cubed plus x squared plus 1. Write a rule for g and then graph each function. Describe the graph of g as a transformation of the graph of f. So for a part it says g of x equals f of negative x. So the negative is inside the parentheses, so we know that that's going to be a reflection across the y-axis. All right, so what we're going to do is we're going to substitute negative x in for our x's in our original equation. All right, so g of x equals f of negative x. So we're going to say f of negative x equals, and then we're going to put a negative x in for x, and then that's cubed, and then plus negative x in for our x squared, and then plus 1. Now we can just kind of clean that up a little bit. A negative cubed is still negative. X cubed is just negative x cubed. So we can just kind of lose the parentheses here. For the next part, it says plus negative x squared. So you know anything squared is positive. So negative 1 squared is positive, and that's just going to be plus x squared. And then plus 1 comes down. So g of x equals negative x cubed plus x squared plus 1. So it says to write a rule, so we did that, and then it says describe it. All right, so it is going to be a reflection across the y-axis. So that's because of the negative here. And it's inside the parentheses, tells us it's the y-axis instead of the x-axis. All right, and the last part says describe the graph as a transformation. All right, so describe it. It doesn't say to graph it, but we can graph it and see what that looks like. All right, so as before, I already have the original function graphed. That just saves a little bit of time. So f of x is x cubed plus x squared plus 1. Now I want to graph the transformation. So negative x cubed plus x squared plus 1. All right, so you can see the blue is f of x. The red here is going to be g of x, or the transformation. So blue, f of x. The red is g of x. So you can see it is a reflection across the y-axis. So this reflects down here and this reflects here. All right, I said that wrong. So this one is a reflection across the y-axis. So this is the y-axis here. So this red line is reflected across this, and this red line here is a reflection across this blue line here. So it is a reflection across the y-axis, not the x-axis. B part says g of x equals 3 times f of x. So we know we're going to have a vertical stretch because the 3 is in front of your f of x. So that would be your a value. So what do? So we're going to take 3 and we're going to multiply it by f of x. So we're going to have 3 times x cubed plus x squared plus 1. So all we have to do is distributive properties. So 3x cubed plus 3x squared plus 3. And that's going to be our g of x. Or 3 times f of x. This one is also g of x. I forgot to write that down, but g of x equals f of negative x in this case And over here, g of x equals 3 times f of x. So all we have to do is take 3 and multiply it by f of x. All right, and we do know it says to describe the graph that 3 is a vertical stretch by a factor of 3. A vertical stretch means it's by a factor of a. So the a in this case is 3. Again, if you want to graph it, let's graph it and look at it just to make sure. All right, again, I have f of x is already graphed in here. That was our original function, and now we're going to graph g of x, which is 3 times x cubed plus 3x squared. I think looking at functions gives you a better sense of what the transformations actually do, and it helps you understand what these movements are doing to the graph. And you can see it still has the same general shape, but it does have a vertical stretch. So that means that graph's going to stretch away from the x. So if you look at this, you can see how it does stretch away from, this is your x-axis, it stretches away from the x-axis. You also can see here that the x-intercept did not change. So that's right here, it says, remember, vertical stretch and shrinks do not change the x-intercept. Okay, it did change the y-intercept, but it did not change the x-intercept of a graph. And it says, yeah, you can observe this here. Example 4, writing a transformed cubic function. Let the graph of g be a vertical stretch by a factor of 2, followed by a translation 5 units up of the graph of f of x. Write a rule for g. All right, so we're going to do this in 2 steps because it's asking us to do a couple things. It says we're going to have a vertical stretch by a factor of 2, and then we're going to move it 5 units up. So our new function is going to be called g of x, okay, the graph of g of x. But since we're going to do this in 2 parts, let's not start with g of x. Let's start with, say, h of x. So let's say the first thing we do is say h of x is simply going to do a vertical stretch by a factor of 2. So because it's a vertical stretch, I know that's going to be a 2 outside of my parentheses. It's going to be 2 times f of x. So it's going to be 2 times all of this function here. So x cubed minus 3x squared. And again, all you have to do is refer back to those key ideas, and it gives you the rules. And if you know the rules, or you can at least follow the rules, then it makes this not too difficult. All right, let's use distributive properties. So we're going to do 2 times x cubed, and we're going to do 2 times negative 3x squared, so negative 6x squared. All right, so that is this first step, okay? So that is taking care of this. Now it says take that, and now we're going to move it 5 units up. So let's take that same function here, and we'll call it g, because this is the last thing we're going to do. So we're going to take this function here, 2x cubed minus 6x squared, and we're going to simply add 5 to move it up 5 units. So that would be our h value. So the new function is 2x cubed minus 6x squared plus 5. Now if you try to do that all at one time, it may get more confusing. That's why I said let's take care of one part first and then do the second part after that. And then it makes it simple. It's just 2 steps, and it makes it simple to get the right answer. Example 5, using a geometric formula. The function v of x equals 1/3 x cubed minus x squared represents the volume in cubic feet of the square pyramid shown. The function w of x equals v times 3x represented the volume in cubic feet when x is measured in yards. All right, so that makes sense because 3 feet equals 1 yard. So they're multiplying this by 3. It says write a rule for w and then find and interpret w of 10. All right, so the first thing we need to do is the same thing as we did before. So let's take and write this as h of x. And the first thing I'm going to do is simply replace our x by 3x. So we're going to have our 1/3. And in place of x, we're going to substitute 3x. Still going to be cubed. And then minus, instead of x, we're going to have 3x again and squared. So now what we need to do is simplify that. So we're going to have 1/3. 3 cubed is 27. X cubed. And then minus 3 squared is 9. And that would be x squared. So 1/3 of 27 is, I don't know, I can't think, 9. 1/3 of 27 is 9. And I don't know why I had my cube on the inside. I got my parentheses in the wrong place, and that does matter. So we're going to have 27x all right, so x cubed minus 9x squared. All right, so 3 times, so this is like, now I've got to distribute this to everything. So 1/3 of 27x cubed. So I'm going to have 9x cubed minus 9x squared. So that's going to be h of x. Now it says to find w of 10. All right, so all we have to do is take our new function here and substitute 10 in place of x. And let's see what that does. So we're going to type it all in at one time. So 9 times 10, and then we're going to cube the 10. And then we're going to minus 9 times 10 squared. And hit enter, and that gives us 8100. All right, so what does the 8100 mean? That means when x is 10 yards, the volume of the pyramid is 8100 cubic feet. So this is 8100 cubic feet. And again, here's a little picture that kind of helps you see what that is. So here's x. If this is 10 yards, because remember we multiplied it by 3 to put it in yards. When this is 10 yards, this whole square pyramid would be 8100 cubic feet. That's all for this example. If you have any questions, please let me know.